Hello, and welcome to a quick walkthrough of the Next Generation Real-Time Data Viewer, which is a project I worked on this summer through the NEES REU program at the University of Minnesota MAST laboratory. The Next Generation Real-Time Data Viewer, or NextGen RDV, or even NGRDV, is the next iteration of the Real-Time Data Viewer, which was created some number of years ago to help researchers view and analyze data in real time as it was coming in during experiments. And the next generation real-time data viewer is trying to build on the original RDV by taking its capabilities to a web format, which will help with keeping the program up to date and also help with sharing data between researchers and aiding in collaboration. So, as you'll see, the Next Generation Real-Time Data Viewer is currently open in Google Chrome, and you'll see that it's currently just a blank page with a navigation and playback controls menu fixed to the top of the page. So, in terms of the navigation menu, we have the header here, the home button, which simply refreshes the page, the connect button, which opens a dialog allowing us to connect to a data turbine database, and the add graph button, which walks us through a series of dialog boxes that allows us to create a custom graph for the page. Below this, we'll see we have a global time slider, and this allows us to select any available time within the current experiment that we have loaded. You'll see that currently the maximum time is August 1st, 2014, 1941:53 GMT, and this is the time that I loaded the page in, and you'll see that if we look down here in the bottom right corner of this screen, it's already 1942 GMT time, so there is a slight difference between the max time of the slider and the max time of the actual max time. And we'll see if we take this playback time, which is tied directly to the right slider handle, all the way back to the beginning, we'll see that the min time is January 1st, 1970, which is the beginning of Unix or epoch time. So, we'll see that if we have a time range here and we want to manipulate the playback time or right slider handle, we can manually input a new time into the playback time field. For instance, taking the 29th of December 1993 to the 29th of December 2005, and if we press enter or click away, we'll see that the slider handle jumps to the appropriate position. Then we have the play button, the pause button, the go to beginning of range button, and the go to end of data button. And so if we press play, we'll see that every 1 second we are incrementing the playback time by 1 second, which is just normal playback. NGRDV will always increment at an interval of 1 second. However, we can simulate speeding up through the data, fast forwarding through the data, or sort of slow motion viewing the data if we so choose, by changing this playback rate. So this is particularly useful for the data turbine, the experiment in the data turbine that I'm going to be loading in shortly, because that experiment only took data from all its sensors once every 10 seconds. So unless we want to sit around and wait every 10 seconds for new data points to show up, we should bump this playback rate up to 10 or something above 10, so that we're getting at least a new point for each graph every second. And you'll see that once we do that, this, instead of the playback time, instead of incrementing every 1 second by 1 second, it's incrementing every 1 second by 10 seconds. And once we're done playing we can simply hit pause, and to go to the beginning of the range we have selected, we hit this button, which simply moves the right slider handle to the position of the left slider handle. And if we want to go to the maximum time available, we hit this button, which takes us all the way to August 1st, 2014. So, if we now wish to connect to the data turbine that we have up and running, we can open the connect dialog box, and from here we have to specify a host and port, and the default values I have in here are just the ones that work for the data turbine that I have running. You'll probably need to specify something different here, but once you have that accurate and just how you want it, hit connect, and you'll see that the playback time jumps from something in like 1990s to sometime in 2014, which was when this experiment took place. And you'll see if we put the playback time all the way to the maximum, that the experiment ended on the 22nd of May 2014, and if we push this all the way back to the beginning, it started on the 14th of May 2014. So we have a little over 1 week's worth of data here, which is alright, but it does make viewing very specific time ranges challenging, which is where manually inputting a playback time using the playback time input field is useful. If we wanted to say bump this up by 4 minutes, just hit that and you'll see that slightly moves over to accommodate the new range. So now that we have this reasonable time range here within the experiment, we can click to add a graph, and this will take us to the first box in the add graph dialog box series. And you'll see that the first field we have here is the unique ID field. Generally, you will just want to leave this alone. It is automatically generated when you hit the add graph button. It is simply the time in milliseconds from epoch, or the beginning of Unix time, at the point at which you hit the add graph button. And this is simply done to distinguish between graphs when we're updating graphs, so that we don't mix up the data and don't give some data to a graph that was not intended to receive that data. So we're actually plotting the right data. And then after that, we have the graph type field. Currently we have two fully functional graph types, line graph and scatter graph. They're very similar, but we're just going to stick with line graph for now. Then below this we have the title and subtitle. I don't have anything specific I really want to call them, but I'll put title and subtitle in there just so we can see how big they are, where they show up, etc. Then below this we have the initial size settings, and I happen to know that for the particular computer and monitor that I'm using, that that a width of 2525 pixels and a height of 1200 pixels works especially well. Then if we proceed to the next dialog box, you'll see that the only thing we do here is select the number of series from 1 to 5 that will be included in our graph. Most of the time you're just going to stick with one series. You might have two if you're comparing the data between two sensors. 5 is a little much. Usually you're just going to stick with one. So hit continue once you've selected that. And then here you can see that we can specify the series name, which I'll just leave as series 1. We can select a color for the series using this color picker. And then we select the data types and sensors to be used for plotting this particular series. So this is slightly more complicated. You have x-axis data type and y-axis data type, and both of these can either be time or sensor, and they're independent of one another. And then you select the sensors that correspond to the x-axis and the y-axis. So what this means is if you were to want to create a displacement versus time graph, or to simplify it a little bit, just a distance versus time graph, you would want to switch the x-axis data type to time, and then have the whatever displacement or distance sensor you wanted for the x-axis sensor and the y-axis sensor, because you're taking the time values from that sensor to be plotted as the x values for the graph, then you're taking the displacement or distance values or sensor values from the displacement sensor that you're specifying for the y-axis sensor. However, in this case, I know that I want to plot a force versus displacement graph, and I know a couple sensors that work well for this within the data turbine that I have running. So I will just select this displacement sensor for the x-axis and the force sensor for the y-axis, and that will give me a force versus displacement graph. And if we hit continue, we're taken to the last dialog box in the add graph dialog box series, which is where we specify some general other information about the graph. First, we have whether we want to include a key or legend in the graph, and we usually want to check this. It's useful because we can see the series name next to the series series color, so it's easier to identify the series on a graph. And we can also click on the series as they show up in the key to turn on or off the visibility of those series. So that's really useful. Then we have horizontal grid lines and vertical grid lines. Oftentimes you'll just want to have these checked. They're just the grid lines that are in either direction on the graph. Not to be confused with the axes, which are just automatically added in there. Then we have the zoom X and zoom Y options, which are basically determining whether you want to be able to zoom in the X direction and whether you want to be able to zoom in the Y direction. Almost always you want to have both of those checked. The X-axis label will just stick with displacement to keep it simple, and the Y-axis label will use force for that. Then when we're done with that, we hit finish, and we'll see our graph shows up, and it has graphed this time range that we see right here in the global time slider. So if we look at our graph, we can see we have the title and subtitle as we specified them, the y-axis label, the x-axis label, the key, which we can use to turn on or off the visibility of Series 1, and we have the X button to close the graph, to delete the graph in the top right corner if we so choose, and the export or chart context menu in the top left corner. And this is interesting because it gives us another a number of ways to either print the chart or download the chart as a particular file format. And of particular note is the SVG vector image. If we click to download that and open it, it'll automatically just open in Google Chrome by default. We can see what looks like a normal image of the graph, but it's especially useful because scalable vector graphics are not based on pixels but rather vectors, so when we blow this image up to a much greater size, it's not going to decrease the quality of that image at all. It'll still look just as nice as it does in this size. So if we go back to the graph, we can begin to change the time range of the data that's plotted on the graph. So if we move one of these slider handles and release, we'll see that the graph updates to reflect that new time range. And if we hit the go to beginning of range button, we just get this 1 point because the two slider handles have centered in on that 1 point. And if we hit play from here, you can see that every 1 second we get a new point, and a new line is drawn between that point and another point on the graph. And if we increase the playback rate, we get more points added every second, as if we're playing through the data at an accelerated rate. And this works well until you get a large data set, in which case high charts will tend to slow down and you do get some performance issues. So the only thing left to explain is the live view button, which if we had real-time live data coming in, would clear all the graphs on the page, then redraw them with any data that is between this maximum time, the 22nd of May 2014, and the current time which is August 1st, 2014. And then after that, all the graphs will update at an interval of 1 second to add the next second of data from the data turbine that's available. So this will essentially graph all the data that you couldn't actually select with this time range, and then graph any new data that's coming in. So that about wraps it up. I hope that next generation RDV proves useful for your research or general data viewing needs, and hopefully in the future NGRDV can be expanded to add more graph types to polish up the user interface somewhat, and possibly to add support for more types of databases and more general use of the live view features. So thanks for watching. Thanks for tuning in. Goodbye.